Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good night everyone. Okay, in this session, we are going to revise stiffness matrix analysis of truss. Okay, so I have chosen example question, okay, from internet. Okay, just look at this truss. So this truss has 4 nodes. This truss has 4 nodes, node number 1, node number 2, node number 3, node number 4. And normally node number in stiffness method, okay, we label under the circle. Okay, node represent joint. So actually in this truss there are 4 joint. There are 4 joint, 1, 2, 3, 4. Okay, so one member, uh, to get member, we have to member consists of 2 join. So we have here three members. Okay, member number 1 joining node number 1 and node number 3. Member number 2 joining node number 3 and node number 4. Member number 3 joining node number 2 and node number 3. So element number normally will be labeled in the box as shown. Okay, there are 3 members and 4 nodes. And in truss, there are 2 degree of freedom in x and y direction per nodes. So in total, we have 8. 8, 4 times 2. So in total, we have 8 because we have 4 nodes. 4 nodes. So we have to times by 2 degree of freedom. So in total, we have 8 degree of freedom in x and y direction per node. Okay. So in this question, question number 1, we have to determine the horizontal and vertical displacement at joint 3. At joint 3. Okay, joint 3 is actually the unconstrained system. So in truss analysis, we should understand about the term unconstrained and constrained. At unconstrained system, there are unknown displacement because there is no support. Unconstrained means no support because constraint refers to support. Constraint refer to support. So unconstrained means unknown displacement. There are unknown displacement in unconstrained system. Okay. So we have to determine the horizontal and vertical displacement at node number 3. At node number 3 because it is unconstrained. So node number 1, node number 2, and node number 4 in this diagram, uh, it has pin support. Pin support. So this pin give the truss six unknown reaction. 6 unknown reaction. Okay, so this 8 we have to divide into unconstrained and constrained, and we normally identify DOF in constraint based on the number of unknown reaction. So number of unknown reaction, we just need to refer to the support. There are 3 pin support. 3 pin support means there are uh, two per node. So there are 6. So it is 6 degree of freedom. So there are 3 pin support at node number 1, node number 2, and node number 4. So this 3 pin support give the truss 6 degree of freedom under constraint system. So from this we know that we have remaining 2 degree of freedom under unconstrained system. So in constraint, 6 degree of freedom refers to unknown reaction. 6 degree of freedom refers to unknown reaction QU, unknown reaction QU, and 2 degree of freedom in unconstrained system refers to unknown displacement DU. Unknown displacement is DU, D unknown, Q unknown, unknown reaction. Okay, we based on the support condition. Okay, so this is the first thing that everyone should do. So we have to be able to identify how many degree of freedom under unconstrained system in an constrained system. Okay, so this 2 degree of freedom here actually refers to the question number one, horizontal and vertical displacement at joint 3. Okay, because it refers to unconstrained system and there are two unknown displacement, one in x direction, one in y direction. Okay, question number two, determine the force in each member. Question number two, determine the force in each member. Force in each member. So question 2 refers to question number 1 as well. Okay. So first thing to do before we start analysis, first thing, so we have to make sure in the diagram, we have to make sure that there are 5 important things inside the diagram. Number one, we have to make sure that there are not number, element number, and then degree of freedom level. Degree of freedom level. And after that, we have to make sure that in the truss, uh, it has arrow, which is parallel with the member arrow, and lastly is coordinate. So five things that we need to make sure it is inside the truss. Number one is node number. Number two is element number. Normally these two will be given element number in the question. Number three, we have to label degree of freedom number according to unconstrained and constrained system. Means that we have to label start from one in unconstrained system, then only we followed by constrained system. So okay, step number four, the truss must have arrow. So this arrow is important because from the arrow we will identify near end and far end arrow. And number five is coordinate. Coordinate. We must have arrow. We must have coordinate. Okay, so we have to make sure that the truss have all these five information. And by looking at this truss, so we have to label degree of freedom. We have to label degree of freedom. So to label degree of freedom, according to unconstrained and constrained system, so normally we sketch the diagram, the truss, okay, under two condition. One is unconstrained, one is constrained. So we just need to sketch like this, sketch only. Okay, and then we label the node 1, 1, 2, 3, 4. Okay, tak label pun okay, doesn't matter. Okay, unconstrained, constrained. Okay, now looking at the truss. Okay, look at the support. Look at the support. At support position, we draw the degree of freedom in X and Y direction. So we put 2, 2, and 2. Okay. So all these pin support. Represent pin support. And please remember, we have to follow the sign convention for truss, for stiffness method, uh, for truss. Okay, so we have to follow x and y direction like this. X and y direction like this. So there are 6 degrees of freedom in constraint system, which is referring to 6 unknown displacement. Pada pin support ada dua, so we have 6 unknown displacement. So we just need to label the degree of freedom like this. Okay, so since from this we can see that there are six have been labeled, so we should fulfill the other two. Okay, the other two in unconstrained system. In unconstrained system. Okay, so now we have eight. We have eight. And to label, we have to start with unconstrained. Unconstrained. So 1, 2, then we continue 3, 4, 5, 6, 7, 8. Okay, so means that we have divide the system into two condition. Okay, there are two unknown displacement, 1 and 2. 1 and 2 refers to D1 and D2. D1 and D2 because label tu 1 dengan 2. So under unconstrained ada unknown displacement because pada unconstrained ni pada note number 3 sebab tak ada support, dia boleh gerak. Dia boleh gerak vertically as well as horizontally. So dia akan ada movement. So that movement we call as unknown displacement. Okay, so 1 and 2 because the label at note number 3 is 1 and 2. Okay, constraint system has unknown reaction. Unknown reaction we label, kita just follow je numbering yang ada pada constraint system, means that these are the unknown reaction label 3, 4, 5, 6, 7 and 8. So inilah dia what we call as unknown reaction and unknown displacement. Unknown reaction and unknown displacement. Okay. Okay, so we have to have the full structure with all the label inside. All the label inside. Okay. Note number 1, 2, 3, 4. 1, 2, 3, and 4. Okay, element 1, 2, 3, 1, 1, 2, 3. Element 1, element 2, element 3. Okay, so for the degree of freedom label, it is 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is for degree of freedom label. And don't forget we have to put arrow, okay, for element number 2. So let's say it is like this. So arrow we can put in any direction that we like. Okay, just put the arrow, and last we have to put the coordinate. We have to put the coordinate. Okay, to label the coordinate, normally what we do is we will choose one node as origin. Let's say in this case, node number 1 as origin. So this will become 0, 0, 0, 0. And from this origin, we have to label we have to label the remaining lah. Okay, so we have, okay, 0 0 0 0, we have 1.8, 0 1.8, 0 1.8. So here is 0 1.8. Okay, then we have 1.2 and 0.9. 1.2, 0.9. This is 1.2, 0.9. And then 3, 0.9. 3, 0.9. Okay. Then only we can start. Then only we can start. Step number 1, we establish element stiffness matrices. Okay, the concept in stiffness method is when we want to analyze structure, we will divide the truss or the structure into element. That is why we have to start with establish the element stiffness matrices K1, K2, and K3 one by one. One by one. Okay, we will start with K1, and for calculating K1, we have to calculate Cx and Cy first, because inside the formula we have to have Cx and Cy. Okay, element number one we have. Okay, now I want to extract element number one outside. Okay, like this. Okay, this is node number 1, node number 3. This is node number 3. This is element 1. Okay, and 5, 6 here. And then 1, 2. This is 1 and 2. So for the coordinate, it is 0, 0. It is 0, 0, and 1.2, 0.9. 1.2 and 0.9. Okay, so this is for element number 1. Element number 1. So from this element, okay, from the free body diagram for element number 1, we should start with calculating Cx and Cy. Cx and Cy. So for Cx, okay, for Cx, we use the coordinate x value far minus near. Far minus near, far is 1.2, 1.2, far minus 0, far minus near, divide by length. Okay, length for this, okay, this is 1.2, 0.9. Okay, the length is 1.5, 0.9, 1.2, 1.5. So this is 1.5. So 1.2 divided by 1.5, it is 0.8. 0.8. Okay, for CY we get coordinate look for CY. We have to look at coordinate Y. Coordinate Y is 0.9. So it is 0.9 minus 0. You divide by length is 1.5. It is now 3 over 5. So this is 0.6. 0.8 and 0.6. Okay, now only we can produce K1. K1. And K1, okay, K1 is in terms of EA. In terms of EA, don't forget we have the most important thing is for each element, for each element, the K, we should label the degree of freedom correctly. So by looking at this element and look at the arrow, so we actually from the arrow, node number 1 is near end, node number 3 is far end. From the arrow, from the arrow, 1 is near end, 3 is far end. And to label the diagram, to label the element stiffness matrix, we will label start from near. So we will label the K1 as 5612. 5612. So this is 5, 6, 1, 5, 6, 1, 2. Okay, and we should actually label 5612 here also. 5612. So that the value in K1. So it is Cx square divided by L. Cx square divided by L. It is Cx square divided by L. Cx is 0.8. Okay, Cx square divided by L. Cx square is 0.8 square. 0.8 square divided by length. Length is 1.5. Cx square divided by L. So it is 0.427. Okay. So we should get also 0.427 here. This one is negative 0.427. This one is negative 0.427. Okay. So next value is CXCY. CXCY 0.6, 0.8 divided by 1.5. CXCY divided by L. The formula as given in appendix. Okay, it is 0.32. Okay, so this one is negative 0.32. This one is negative 0.32. This is 0.32. 0.32 and 0.32. Okay. Next value is cy square over L. And cy is 0.6. 0.6 square divided by 1.5. 0.24. 0.24. 0.24 is 0.24. This one is negative 0.32. 0.24 negative. This one is negative 0.32. This is negative 0.24. Okay. So this is K1. This is K1. So please check. So this is 5, 6, 1, 2. Okay, in terms of EA, the formula is EA over L, Cx square, Cx Cy, negative Cx square, negative Cx Cy. Okay, and for the truss, so please make sure that, so under the matrix, this 4 value equal to this 4 value. Okay, inside all element stiffness matrix for truss. Okay, and then this 4 value equal to this 4 value, the same value, but it is negative. Okay, the same but negative. That is why we get like this. Okay, so refer formula, so we should get like this. Okay, so make sure the K1 is labeled correctly. Okay, it is 5612. We define based on the arrow. Okay, so we continue the same for element number 2 and for element number 3. Okay, so for element number 2, arrow is like this. This is element number 2. Node number 3, and then node number 4. The label is 1, 2. Label is 7, 8. 7, 8. Coordinate. So this is 3 and 0.9. This is 1.2 and 0.9. Okay, and for horizontal member, Cx is 1, Cy is 0. For horizontal member, the arrow is moving towards right direction from 3 to 4. From 3 to 4, so Cx is equal to 1, Cx is equal to 1, Cy is equal to 0. For horizontal member. For vertical member, Cx 0, Cy 1. Okay, so based on this, we can produce K2. K2. The length for K2 is 1.8 meter. The label is 1, 2, 7, 8. It is 1, 2, 7, and 8. Okay, we just need to follow the label inside the diagram for element 2, 1, 2, 7, 8 from the arrow 3 to 4. Okay, so we have Cx square divided by L. Cx square 1 divided by L is 1.8. Okay, so we will have 0.556. Cx Cy we get 0. This one the same but negative, 556. This one 0. Okay, so it is metric, so it has to follow the metric characteristic. 556 and 0. Okay, and this one we will get 0. This one also we will get 0. This is also 0. This is also 0. Okay, this is also 0. This is 556, 0, the rest 0, 0, okay, 0. Okay, this is 1, 1, 2, 7, 8. 1, 2, 7, 8. 1, 2, 7, 8. This is K2. This is K2. Okay, next is element number 3. Element number 3. And for element number 3, so it is 3, 4, 1, 2. Like this. It is 3, 4, 1, 2. The arrow is like this. This is element number 3. Okay, joining. This is node number 3 and 1. 1 and 3. No, 2 and 3. This is 2. This is 2 and 3. Okay, and for coordinate, so this is 0. This is 0, 1.8 and 1.2, 0.9. Okay, so this is element number 3. Element number 3. So we should start with calculating Cx and Cy. Cx and Cy. Cx and Cy. So look at the arrow. So far, this is far end. So this is near end. It is far minus near. Far minus near. 1.2 minus 0 divide by length. It is 1.2. It is 1.2. We minus by 0. 1.2 minus 0. 1.2 minus 0 divide by the length. Length is 1.2, 0.9. It is 1.5. Okay, so this one is 0.8. 0.8 and Cy is far minus near. Far minus near means 0.9 minus 1.8 divide by 1.5. So this one is negative 0.9. Negative 0.9 is negative 0.6. So we get Cx 0.8, Cy negative 0.6. So this Cx and Cy we substitute into the formula. Okay, we substitute into the formula. Okay, so this one is K3. K3, the label is 3, 4. 3, 4, 1 and 2. 3, 4, 1, 2. So Cx square. Cx square means Cx square means 0.8 square. 0.8 square divided by length. Length is 1.5. So we will get 0.427 positive. 0.427 positive. Okay, value number 2. For value number 2, it is Cx, Cy. Cx, Cy, same value, but this one is negative because Cy is negative. Cx, Cy. Okay, so this will become positive. So this is negative. This will become positive. Okay, it is a negative, positive, negative, negative, positive, positive, negative, negative, positive. Okay, so this one is negative, positive, negative, positive, positive, negative. Okay, Cx, Cy square 0.24, 0.24, 0.32, 0.32. Okay, so here, okay, you check first. Here is positive, negative, positive, negative, negative, positive, positive, negative, negative, positive. Okay, negative, negative, positive. Okay, this is positive, positive. And please check. Okay, this 4 value must equal to this 4 value. Means that this is negative, negative 0.32, 0.24, 0.24. So this one is positive. Okay, it should be negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. And then this is negative, positive, positive, positive. Okay. Okay. So this is, so we just need to follow the formula. Okay, the formula for this is cx square cx cy, negative cx square negative cx cy. That is the formula. Okay, that is the formula. So this one is cy square. Okay, that is why we get like this. Okay, so we label 3412, 3412. Okay. Okay, now we should combine to have stiffness matrix. Okay, it is 8 by 8, 8 by 8, 8 by 8. Okay, so this is 8 by 8, yeah, matrix 8 by 8, because the truss has 4 nodes, so in total there are 8 degree of freedom. So for the structure stiffness matrix, we label in order 5, 6, 7, 8, 5, 6, 7, 8. Okay, so we will calculate one by one. Okay, find the value at each position in the K. Okay, using K1, K2, and K3. Okay, using K1, K2, and K3. So for position 1, 1, for position 1, 1 is this 1, 1. This is also 1, 1. And this is also 1, 1. So plus all this. Okay, 1, 1. So it is 0.427 plus 0.556 plus 0.427. So we get 1.41. Okay, we get here is 1.41. Okay, so next is position 1, 2. 1, 2. Position 1, 2. This is 1. This is 1, 2. Sorry. This is 1, 2. 1, 2 to 1 is the same. 1, 2 to 1 is the same. 1, 2, 0. 1, 1, 2. So it is 0. The answer is 0. The answer is 0. Okay, next is 1, 3. 1, 3. So we can only find 1, 3 in K3. We can only find 1, 3 in K3, and the value is 1, 1, 1, 3, and the value is negative 0.427. Negative 0.427. And then 1, 4 also we can only find in K3. 1, 1, 4. 1, 4 for 1 is the same. 1, 4 for 1 is the same. It is 0.32. 0.32. 0.32. 0.32. Next is 1, 5. 1, 5 is in K1. K1. 1, 5 is 0, negative 0.427. Negative 0.427. Negative 0.427. This is 1, 5. Okay, 1, 6. 1, 6. 1, 6. 1661 is the same. 1661 is the same. It is negative. Negative 0.32. 1661. Negative 0.32. Negative 0.32. And then 17. 17 is inside K2. Is inside K2. So 1771. Negative 0.556. Negative 0.556. Okay, and 18. 18 is 0. 18 is 0. 0. Okay, so this is for line number 1. Line number 1. Okay, now we move to line number 2, and since it is symmetry matrix, so we will start with 2, 2. Okay, we start with 2, 2. So find 2, 2. So this is 2, 2. 0.24 plus 2, 2. 0 plus 2, 2. 0.24. It is 0.48. For position 2, 2, it is 0.48. Okay, next is position 2, 3. Position 2, 3 is inside K3 only. 2, 3. 2, 3, 3, 2 is the same. 0.32. 0.32. The next is 2, 4. Also in K3. 2, 4 is negative 0.24. Negative 0.24. Okay, next. 2, 5. 2, 5 is inside K1. Okay, K1. 2, 5. 5, 2. Negative 0.32. Negative 0.32. negative 0.32. Okay, 25. Next is 26. 2662, negative 0.24, negative 0.24, negative 0.24, 26. Okay, next is 2728, 2728, 2728, 2728. 2728 is 00. 2728, 0, 0. Okay, so that is for line number 2. So for line number 3, since it is symmetry matrix, so we should start at position 3, 3. And position for 3, 3, it is inside K3. So 3, 3 is 0.427, 3, 3. 0.427, 3, 4. 3, 4 is negative 0.32. 3, 4 is negative 0.32. 3, 5. 3, 5, no intersection. It is 0. 3, 5, 0. 3, 6 also 0. 3, 6, 0. No intersection. 3, 7, 0. No intersection. 3, 8 also 0. No intersection. Okay, no intersection. Okay, now we move to 4, 4. We move to 4, 4. Okay, 4, 4 is also inside K3. The value is 0.24. 0.24. 0.24. Okay, next is 4, 5, no intersection, 0. 4, 6, no intersection, 0. 4, 4, 7 also no intersection, 0. 4, 8 no intersection, 0. Okay, next we move to 5, 5. 5, 5 we can find inside K1. Inside K1, 5, 5. 5, 5 is 0.427. 5, 5 is 0.427. This 5, 5. Okay, then 5, 6. 5, 6, 0.32. 5, 6 is 5. 0.32. Okay, and then there is no intersection for 5, 5, 7 and 5, 8. So this will be 0, 0. Okay, next we move to 6, 6. 6, 6. So 6, 6 is inside K1. 6, 6 is 0.24. 6, 6 is 0.24. 0.24. 6, 6. 6, 7, 6, 8. No intersection. 6, 7, 6, 8, no intersection. We cannot find 6, 7, 6, 8 in all the K1, K2, and K3. So means that there is no intersection. Okay, 7, 7. 7, 7, 7, 7 is inside K2, 0.556. 0.556. 0.556. And 7, 7, 7, 7, and 7, 8. 7, 8 is 0. 7, 8 is 0. And lastly is 8, 8. 8, 8 is 0. So 8, 8 is 0. Okay, so this is the matrix. This is what we call as the structure stiffness matrix. It is written in order. In order means from 1 to 8. So we label 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We label for the line and for the rows. Okay, so it is in terms of EA. Okay, now to solve for the unknown displacement, to solve for the unknown displacement, okay, since there are only two unknown displacement, so it is enough to have 2 by 2 matrix actually, 2 by 2 matrix actually. So this is what we do if the question asks us to calculate or to establish in full K structure stiffness matrix. But based on the question given, we don't need to give in full. We give in full like this whenever in the question there is a question stated establish like this, yeah, establish structure stiffness matrix. Establish structure stiffness matrix, then only you have to give both 8 by 8. Okay. However, if inside the question there is no sentence mentioned about giving the whole structure stiffness matrix, we just need to focus on unconstrained system only. Okay, back to the diagram, unconstrained and constrained. In unconstrained system, we have only 2 degree of freedom. Means that we have to write the stiffness equation or the force displacement equation by only considering unconstrained degree of freedom system. Okay, so for the stiffness equation, it is Q is equal to Q is equal to KD. Q is forces, nodal forces. Q is nodal forces. K matrix, structure stiffness matrix. D is nodal displacement. So what we want to solve this is only 2 by 2 matrix. 2 by 2 matrix. So we focus on that only. It is 2 by 2 matrix. Okay. So what we want is at uh, at position number 1 and position number 2. Position number 1 and position number 2 represent Q1 and Q2. Represent Q1 and Q2. Q is equal to KD. K we want K because we focus on 2 unconstrained means 2 by 2 matrix. 2 unconstrained means 2 by 2 matrix. Okay, displacement again, displacement under unconstrained system, we must consider 1 and 2 only. 1 and 2 only. So actually we just need to produce this big. Okay, we just need to produce big. This is stiffness equation format. Okay, stiffness equation format when we want to solve for the unknown displacement. When we want to solve for the unknown displacement, you don't have to calculate until 8 by 8, but only focus 2 by 2 matrix. Okay, until position 2 2 in the matrix. Okay, so Q, so this is for the first one. The first one is for position Q1. For position Q1, okay, this is Q capital, we use capital. This is Q1 and Q2. Q1 and Q2, because Q1 and Q2 is not reaction. Q1, Q2 is not reaction. Reaction start from Q3. Means that we have to replace this Q1 and Q2 with numbers. Okay, with numbers. Okay, now we have K. This is actually K11. This is actually K11. Okay, K11. Okay, 1, 2 for the position. And then 2, 1. K, 2, 1. And K, 2, 2. So this is K, 2, 2. Okay, 1, 1, 1, 2, 2, 1, 2, 2 is called as stiffness matrix. Stiffness matrix. Okay, corresponding to unconstrained system. Okay, this is displacement. Displacement, position 1, position 2. Displacement, position 1, position 2. Displacement, this is D1. D1 is unknown, and also D2. D2. D1 and D2. Okay, this is the format, actually the format of stiffness equation. So what we need to do is we have to replace all the known value inside this, and after that we will solve for the unknown displacement. Okay, the unknown displacement are D1 and D2. D1 represent horizontal displacement because one is in horizontal direction, 2 is in vertical direction. So D1 represent horizontal displacement at node number 3. D2 represent vertical displacement at node number 3. If we refer back to the question, okay, horizontal displacement at joint 3, vertical displacement at joint 3. Horizontal displacement at joint 3, we label as 1. We label as 1. Vertical displacement at joint 3, we label as D2, D1 and D2. Okay, so the rest we have to substitute with value. Okay, Q1 and Q2. Q1 and Q2 means that Q at position 1. Position 1 refers to horizontal direction. Means that Q1 refers to horizontal force at node 3. Horizontal force at node 3. So refer back to the diagram, the main diagram. Look at node number 3. So find the horizontal force at node 3. Okay, so since there is no value representing horizontal direction at node number 3, means that Q1 is equal to 0. Q1 is equal to 0. 0. Okay, then Q2. Q2. Q2, position 2 is located under node number 3. Under node number 3, it is in vertical direction. It is in vertical direction. So means that Q2 is force in vertical direction. Force in vertical direction. Force in vertical direction. Okay, at node number 3. At node number 3, so it is given as 20 downward. 20 downward. So we have to compare back with the label that we put. Okay, the label for the vertical direction we label as 2. The arrow is upward. Okay, the force is downward. So that is why the value that we should put into Q2 is negative. Negative. So this is negative 20. Negative 20. Negative 20. Okay, negative 20. Okay, K value we just need to find from this. Okay, 1.41, 0. This is, okay, don't forget it is in terms of EA. It is in terms of EA. It is 1.41. 1.41. K2 is 0. K2 is 0. K2, K12, not K2. K21 is position 21 is also 0, and position 2 is 0.48. 0.48. Okay, so this is the stiffness equation. This is the stiffness equation corresponding to unconstrained degree of freedom system only. So it only has 2 by 2 for the stiffness matrix. Okay, because we only consider unconstrained system. So from this, we should continue to solve D1 and D2 using simultaneous equation. Okay, just use calculator, find D1 and D2. Find D1 and D2. Okay, let me check first. Okay. Okay, to insert into calculator, we have to choose equation. We have to choose equation. Okay, doesn't matter. Okay, to insert into calculator, so what we should do is we have to insert the value of A1, B1, C1, and then A2, B2, C2 into calculator. So A1, okay, always remember that A1 start from this. This is A1, because the formula, the format inside the formula is A plus B equal to C. A plus B equal to C. So this is A1. So this is A1, this is B1, this is C1. Okay? And this is this is A2, this is A2, this is B2, this is C2. Okay, so we put all this into calculator, and then we will get the answer in terms of EA, because we don't substitute EA, so we get in terms of EA. Okay, so we get D1 and D2. Okay, we get D1 and D2. Okay, in terms of 1 over EA. 1 over EA. 1 divided by EA. Okay, 1 over EA. Okay, D1, after I substitute into calculator, D1 is 0. D2 is negative 41.667. Okay, and in the question, EA is actually given. So to find the final answer for D2, we just need to substitute EA into this. Okay, so back to the question given. It is 300 and 200. 300 and 200. As usual, we have to check whether the unit is okay. So it is 200 times 10 power of 6, 200. GPA we have to change to a kilo Pascal, and A is 300 times milli. Milli is negative 3. So it is 10 negative 6. 10 negative 6, negative 6. 10 negative 6, so it is 200 times 300. 200 times 300. Okay, so we just substitute. It is 41.667 divided by 200 times 300. So the answer is 0. Okay. There is no horizontal displacement at node number 3 because there is no horizontal force. There is only one force, which is vertical force at node number 3. That is why support join bukan support join D tu, join 3 tu, dia akan move downward. Dia ada horizontal vertical displacement, not horizontal displacement. There is no horizontal displacement sebab tak ada pun horizontal force given in the question. If horizontal force is given in the question, then dia akan adalah D1 value which represent horizontal displacement. D2 represent vertical displacement sebab ada 20 kilonewton tadi. Okay, so that is why we get horizontal displacement. Vertical displacement. Vertical displacement. So this D2 we get from 41.667. Okay, we divide by 200 and 300. So we get negative 0.000069445. Okay, so meter. Okay, so this is the answer for D1 and D2. So horizontal displacement equivalent to 0. So it is correct because there is no horizontal force, okay, applied into the system, and D2 is negative, okay, 0.000069445, okay, negative, okay, because it deflect downward. Okay, the answer. Okay, so check back so that is the answer for question number 1. Question number 1, this is how we analyze for the unknown displacement using stiffness matrix method. Okay, so question number 2 is for the member forces. Member forces, we use actually formula. The formula to calculate member forces, please remember, because it will not be given in final exam. Formula to calculate member forces, please remember. Okay, inside the formula you will only be given the formula for K as well as formula for fixed end reaction. There is no formula given to calculate the member forces, so please remember that. Okay, so I will stop right now. I will inshallah continue to calculate the member forces, okay, using this example in the next video. Okay, I will let you know the next video. Okay, when is the next video, okay, session. So thank you very much. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.